It's Algebra 2 lesson 6.5, the remainder and factor theorems, part 2, picking up from yesterday's lesson. A factor theorem, a polynomial f of x has a factor x minus k if and only if f of k is 0. So it's going to turn out to be 0 when you subtract it from it. Watch, I'll show you what that means. Example number 3 is factoring a polynomial. It says f of x is equal to x cubed minus 19x minus 30, given that f of 5 is equal to 0. So what that's saying is that when you subtract 5 minus 5, whatever the number happens to be, when you take the opposite number of it, you subtract it in this case, it's going to give you 0. So because f of 5 is 0, you know that x minus 5 is a factor of f of x. So then we just use synthetic division. All you need to know about this, is what I said, it's easier than it looks. All you need to know about this is whatever this number happens to be, in this case it's 5, that's the number you divide by. So what you want to do from there with synthetic division is you want to use all of your coefficients. Again, just like the one we looked at a second ago. Notice that a degree is skipped right here. It goes from x to the third to x to the first power. It skips x to the second. So when you're doing your degrees or you're doing your coefficients, notice this 0 right here. That represents x to the second. So we have 1x to the third, 0x squared, negative 19x to the first, and negative 30 is the constant term. So again, that 0 is the placeholder one, but that makes a difference when we go to put our variables back onto all of our coefficients. Again, synthetic division, all we do with this first number is bring it straight down. So it goes right here. After that, you multiply that number times 5. 1 times 5 gives you 5. Then you combine that column. 0 and 5 gives you 5. You multiply that number times 5, and you get 25. You combine that column, negative 15 and 25, to get 6. And then one more time, you multiply 6 times 5 to get 30. And you combine 30 and negative 30. Now, oftentimes, and it hasn't happened in the first few examples we looked at, oftentimes the last column, you're going to have opposite terms like this, 30 and negative 30. More often than not, you'll see 0 at this last step. So you won't have to worry about making it a remainder, whatever that number happens to be, over x minus 5, because it's 0. So when we put that number back in, or we put all of those coefficients back in, we're going to add the variables to go with them. So right here, the first one is this right here, 1. And remember, you go 1 degree less than whatever this is. So it's 1x squared. Then the next one is plus 5. That's x to the first power because x squared was first. Then the next one is plus 6. We already got x squared. We got x to the first power. We got the constant term. And then plus 0. There's no reason to write plus 0 over anything. So this x squared plus 5x plus 6 is the same thing here. So our factors then, one of them is x minus 5. That one came from the fact that f of 5 was equal to 0. All you need to do is take whatever that number is, x, and subtract 5 from it. Whatever that number in the parentheses is, its opposite term is the easiest way to look at that. From here, now we have a trinomial that we can easily simplify. We can easily factor out whatever this trinomial is. We know how to do this. We take ourselves 2 sets of parentheses. We do x times x, and then we do our factors of 6, our number c. We could either use 1 and 6 or 2 and 3. Both of them get you to the number 5. 1 and 6 get you to 5 by subtracting them. 2 and 3 get you to 5 by adding them. So you have to determine which pair to use based on looking at this sign. That sign says that they're the same sign. They're either both positive or both negative. So that means you need to add the numbers up, not subtract them. So the only 2 numbers that you can use in this case are the numbers 2 and 3. 6 and 1, you would have to subtract them to make it work. So right there, they're both positive, they're both the same, and they're both positive is what that one says. Plus 2 and plus 3, that's what it says here. So these are our 3 factors, x minus 5, x plus 2, and x plus 3. On the back, let's do this one. F of x is equal to 3x to the third plus 13x squared plus 2x minus 8, given that f of negative 4 is equal to 0. Again, remember, when you see f of negative 4 equals 0 like that, it's talking about x with the opposite number of that. But you're still dividing by what that number is, negative 4. Try that one for about a minute. Okay, I want to talk about the first part of this real quick. If you're not quite finished, take a look at it. Then I'll pause again, let you finish the end of it. The first part, just to make sure you're getting it set up right, is to make sure you don't skip any degrees. X to the third, x to the second, x to the first, constant term. This one doesn't skip any degrees. So use all the coefficients that are shown, 3, 13, 2, and negative 8. Then you have to decide, what do you divide by? It says f of negative 4. That's what you're going to divide by right there, negative 4. So from there, remember, this number goes straight down. It doesn't change. It's 3. That multiplies times negative 4 and gets negative 12. Combine those, you get 1. Continue doing that for a minute and see if you can get to the next step by yourself. Again, one more time, we're going to multiply the last number. We got 1 by that number that's outside negative 4 again. We're going to get negative 4 here. We combine 2 and negative 4, we'll get negative 2. One more time, we're going to multiply negative 2 times negative 4, and we're going to get positive 8. Remember what I told you a minute ago about typically in that last column, you'll have opposite terms. In this case, it's negative 8 and positive 8 to get 0 where we don't have any remainders. That's typically what happens. From here, this is your largest degree. Remember, you go 1 degree less than 3. So this first number 3 right here, 3 is going to be x to the second power, not the third power. The next number is positive 1. It's x to the next lower degree, x to the first power. The next number is negative 2. It's a constant term, so you don't put it times any exponents at all, or any variables at all either. And then the remainder is 0. So here is your trinomial 3x squared plus x minus 2. Now, that's the trinomial, that's a factor. The other factor comes from f of negative 4 is equal to 0, just like on the example that precedes this. It is x, and it's the opposite sign of negative 4. So it's x plus 4 is the other one. From here, you have a trinomial that you can factor out. We already have x plus 4, so you can factor out this trinomial. Even though its a value is not 1, it has an easy a value, 3, because it has to be times 1 to get 3. So it only has one pair. And 2, our C value also only has one pair, 1 times 2. So we know we got to use the numbers 1 and 2. We got to decide where we want to use them. Do we want to put 3x and 1 in the same set of parentheses, or x and 1 in the same set of parentheses? Which one? We know it's going to be 1 times 2 somehow. So we either want to put 1 here and 2 here, or the other way, 2 in the first one and 1 in the second one. Remember, we're trying to get to the b value, which is 1, this b value right here. So in order to get to that b value, we need to subtract the numbers to get there, since it says negative 2 in front of the c value. So in order to do that, we're going to go ahead here, put our 2 here and our 1 here, and then when we subtract them, we'll get 1. Again, this sign right here says negative. That means they're opposite signs. It means that you need to subtract them. This sign says plus or positive. That means the bigger number out of 2 and 1 is going to be positive. Now, typically, what I just said, the bigger number is going to be positive. Almost true. The bigger number, when you FOIL it back out, is going to be positive. 3 times 1 gives you a bigger number than 2 times 1 does. So since that's the case, this one is going to get the positive number, plus 1, because 3 times 1 is 3, and negative 2 times 1 is negative 2. And when you combine those, you get 1x, or the b value. So 3x minus 2 and x plus 1. And then it's just this last one, x plus 4. So these are your 3 factors of the original problem, 3x cubed plus 13x squared plus 2x minus 8, given that f of negative 4 is 0. Again, this is just synthetic division from yesterday, and then factoring out a trinomial after. So I know this looks confusing, but it's really not. It's what we did yesterday, plus things we did several months ago in this class. The only thing that's added from yesterday is you have to understand that you're going to divide by what that number is right there, negative 4. And then the factor is the opposite of that, x plus 4. Here's example number 4. It says finding zeros of a polynomial function. A 0 of f of x equals x cubed plus 2x minus 2x squared minus 4x minus 4 is x equals negative 1. Find the other zeros. So what it's saying, x is negative 1. So the factor of that is the opposite of that, x plus 1. So because f of negative 1 is 0, and that's all this is saying, it's the same thing as the last example, f of negative 1 is 0. You know that x plus 1 is a factor of it. Just the opposite. It's easier than it looks. It's the opposite of what that says. X, and then whatever the sign is, you change it. X plus 1. So then use synthetic division to do that. Synthetic division is what we did a minute ago. 3, 2, 1, no degrees. They don't skip any. So you use 1, you use negative 4, and negative 4. So that's what we got there. You're dividing by negative 1. So again, same thing we did from yesterday. It's just synthetic division from yesterday. This one comes straight down. Multiply 1 times negative 1, you get negative 1. Combine those two, you get 0. Multiply 0 times negative 1, you get 0. Combine those two, you get negative 4. Multiply negative 4 and negative 1, you get positive 4. And combine those two to get 0. So now you have all your numbers, 1, 0, 4, 1, 0, negative 4, and 4. Go back to your original polynomial. It says x cubed. Go 1 degree less than that. It'll be x squared. So this is your first coefficient. 1x squared. 1x squared plus 0x to the first power. Notice we have a 0 there. Minus 4. There's no degree there, so it won't be times x to nothing. And then plus 0. So again, anytime you have plus 0 something like this, it eliminates that. So notice now we have x squared. You don't need to write 1 up front. 1 times x squared, just x squared minus 4. And that's what we have on this step here. X plus 1 times x squared minus 4. Now this at this step right here, the factor from this step to this next step, you have to know that the difference of two perfect squares, x squared minus 4, When you factor it out, it's x plus 2 and x minus 2. Remember, the difference of two perfect squares, take the square root of the first one and the square root of the second one, and it's just one of them's plus, one of them's minus. Again, that goes back to several months ago stuff we did. So we have three different factors. Now we have x plus 1, and x plus 1 came from the original problem. Since it said x is equal to negative 1, you do the opposite sign, x plus 1. The next one's x plus 2 and x minus 1. So all of this is equal to 0. So if you're trying to find the zeros of this, it's just like solving an equation like this. You make all three of these little expressions equal to 0. X plus 1 is 0. You make x plus 2 0. And you make x minus 2 0. So when you undo all of those, when you subtract 1 on both sides, you get x is negative 1. When you subtract 2 on both sides, you get x is negative 2. And when you add 2 to both sides, you get x is positive 2. So the three zeros that go along with this are negative 1, negative 2, and 2. So again, let's see if we can make a little bit better sense out of that on the follow-up problem that goes with it. Again, on the side, on the back. 1 0 of f of x equals x cubed plus 6x squared plus 3x minus 10 is x equals negative 5. Find the other zeros of the function. Again, it acts just like synthetic division from yesterday. Try that one. Anytime you have something like this, you find in the zeros where it says x is equal to this, or f of x is equal to it, or f of whatever the number is equal to 0, that's what you're going to divide by. So right there, that's what you put in negative 5. However, the factor of it, remember, is the opposite of what that says. So it's not going to say x minus 5. It'll say x plus 5 or positive 5. That's the factor. We'll come back to that in a minute. The next thing you check with synthetic division, make sure no degrees are skipped. The biggest degree is 3. The next one's 2, then 1, then no degree. So your coefficients go next. This one's 1, positive 6, positive 3, negative 10. From there, you go straight down with it. This one is 1. Multiply 1 times negative 5 to get negative 5. Combine those two, 6 and negative 5, you get 1. Multiply 1 and negative 5 to get negative 5 again. Combine those two numbers, 3 and negative 5 to get negative 2. And then multiply negative 2 again times negative 5, get positive 10. Again, like I told you earlier, oftentimes that last column you'll wind up with opposite terms. We just did again. 10 and negative 10 gives you 0. Now we got 4 coefficients. So we go back to our original polynomial. X cubed is the largest degree. This number here goes with the next smaller degree from that. X cubed means x to the second is the first one. The next number is plus 1, x to the next smaller degree, x to the first. The next number is minus 2, and there's no variable term there, so that's a constant. So again, there's no reasons to have ones here, so all it simply says is x squared plus x minus 2. That's one of your polynomials. That's your trinomial, x squared plus x minus 2. Remember, this one is your other factor, x plus 5. So that one goes there. So if you multiplied x plus 5 times this, you would get back to x to the third plus 6x squared plus 3x minus 10. We're not trying to do that, though. We have to go one step further, or two steps further. We have to separate this one into two binomials by factoring it out. We know how to do this. Again, it's been several months, but we know how to do this. X times x gives us x squared. The c value is 2, so we got to use the numbers 1 and 2. There's no other numbers you can use. The negative in front of the 2 tells you they're opposite signs. The positive in front of your b value tells you the bigger number is positive. So plus 2, minus 1. The other one is the one that we had a minute ago, x plus 5. Now we have three factors, x minus 1 times x plus 2 times x plus 5. So the zeros of this are when you set each one of these little things I have in red, each one of these expressions equal to 0. So what you wind up with is opposites of each of these. 1 for this one, negative 2 for this one, and negative 5 for that one. Those are the three zeros of that function. 1, negative 2, and negative 5. Last night you had to do 1 and 2 on your checkpoints. I told you to use synthetic division for both of them, even though it tells you to do long division. So all you have to do for this one is use synthetic division just like this. Remember, it's the opposite of what this says. It says positive 3. That's a factor of it, though, x plus 3. We just talked about that on the example prior to the one we just looked at. So negative 3 is what you divide by. The other thing you got to check, make sure no degrees are skipped. It says x squared, the next to the first, then a constant term. So it's good. Your coefficients then are 1, 4, and negative 1. When you go straight down with this first one, you don't fool with that one at all. That's the only other mistake I see people doing. They'll try to multiply that times negative 3 or something. You don't do anything with that. 1 times negative 3 now is negative 3. Combine those two. 4 and negative 3, you get 1. Multiply 1 and negative 3 to get negative 3. Combine those two numbers right there and you get negative 4. Now we have three different coefficients. So it started out as x squared. That was the original degree. We go 1 degree less than that. 1x to the first power. The next number is plus 1. It's a constant term, so it's not a variable at all. Plus 1. Then the next number is negative 4. There's no variable term. That's a remainder right there, negative 4. So it's going to go over this original factor, x plus 3. There's no reason to write 1 times the variable there. So here is your simplified version, x plus 1 minus 4 over x plus 3. And number 2, the same thing. We have 2x cubed minus x squared plus 3x plus 4 says to divide it by x plus 1. When you're reading the problem, just quickly scan to see if it skips over any degrees. That's an easy thing to check right at the beginning. So when you do your synthetic division, it doesn't skip any degrees. You put all your coefficients 2, negative 1, 3, and 4, and you divide by the opposite of plus 1. So you divide by negative 1. 2 goes straight down, becomes 2. 2 multiplies by negative 1 to give you negative 2. Those combine to give you negative 3. Negative 3. Negative 3 multiplies by negative 1 to give you positive 3. Those two numbers combine to give you 6. 6 multiplies by negative 1 to give you negative 6. and 4 and negative 6 combined to give you negative 2. I went very quickly through that problem. Did anybody not follow the steps that we went through to get to 2, negative 3, 6, and negative 2? Once you have those coefficients, you put them back in to the polynomial form by going to the next smaller degree from the largest one, x to the third. So this number here, 2x squared, not x to the third. The next number is negative 3, and it's just 1 degree less than x squared, so it'll be x to the first power. The next number is positive 6. It's 1 degree less than x to the first power, which is x to the 0 power, the constant term. And the last thing is negative 2. That's your remainder. Negative 2, since it's a remainder, goes over the original x plus 1. 2x squared minus 3x plus 6 minus 2 over x plus 1. Number 3 tells you to factor this one. 2x cubed minus x squared minus 25x minus 12. No degrees are skipped there. Given that f of 4 is equal to 0. Again, when you rewrite this in order to factor this is the same as x, and then whatever the opposite of inside that function right there is. It's positive 4, so the factor is x minus 4. But you divide by whatever it is. So your coefficients are going to be 2, negative 1, negative 25, negative 12. Those are big numbers, but it just comes right off of the coefficients from the polynomial. You're dividing by f of 4, so you're dividing by 4. Straight down with the first one is 2. 2 times 4 is 8. Combine those two, you get 7. 7 and 4, you get 28. Combine those two, you get 3. 3 and 4, you get 12. And like I told you a minute ago, oftentimes you'll have opposite terms in that last column. 12 and negative 12 gives you 0. Synthetic division real quickly right there. From there, put it back into your polynomial form. Remember, this is the biggest degree, 3. We go 1 less than that, 2x squared. The next number is plus 7, positive 7. The next smaller degree is x to the first power. The next number from there is positive 3. The next degree is x to the 0 power. You don't need to write that one. That's the constant term. And then it is the remainder 0. There's no reason to write plus 0. So we have a polynomial, 2x squared plus 7x plus 3. We have this factor right here, x, not that one, I'll rewrite it, x minus 4. So we have to factor out this one here, 2 binomials from a trinomial. You have to use 2x times x to get 2x squared. And we know your factors of C, 3, have to be 1 and 3. So it says plus 3. That means you need to add them up, not subtract them. So in order to get to 7, we need to add them this way, 3 and 1. Again, plus tells you that they're going to be the same. Plus tells you they're both positive 1. So 2x plus 1 times x plus 3 times x minus 4. This is the 3 factors when f of x equals 2x cubed minus x squared minus 25x minus 12, given that f of 4 is 0. And then the last one says 0 of f of x equals x to the 4th minus 5x squared plus 4 is 1. Find the other zeros. Again, quickly when you look at this, you need to notice that it skips x to the 3rd power. So you're going to need to add in a 0 as a placeholder. It says the 0 is 1. So what that's saying is that's what you're going to divide by 1. 1. But the factor is the opposite, x and negative 1. That's the factor right there, x minus 1. The rest of it will act just like everything else. The first coefficient is 1. The next coefficient is x to the 3rd power. That's not represented. You need to represent that with a 0. The next coefficient is negative 5 because that's x squared. The next coefficient, again, is not represented. They don't have x to the 1st power, so you need a 0. And then the last one is 4. Notice we have 5 numbers up here, and only 3 were in the problem. The 2 zeros that I have in blue represent the placeholders, but because they're going to represent a spot that we need to fool with. 1 goes there. 1 times 1 gives you 1. Combine those two, you get 1. 1 times 1 gives you 1 again. Combine those two, you get -4. -4 times 1 gives you -4. Combine those two, again, you get -4. And -4 times 1 gives you -4. One more time, combine those two, you get 0. So we got 1, 1, -4, -4, and 0. We put it back into the polynomial form. This is the biggest degree, x to the 4th power. So this is going to be 1 x to the 3rd plus 1 x squared, that's the next biggest degree, minus 4 x to the 1st power minus 4, and then it'll be plus 0. Again, there's no reason to have 1 as coefficients there. So here's a polynomial that has a 3rd degree, x to the 3rd plus x squared minus 4x minus 4. And the original factor, the one that came from it being equal to 0, was x minus 1. X minus 1. And I don't want you to factor out, just the type of example this is, I don't want you to factor out x to the 3rd power. So we'll stop that one, even though it asks for the zeros. We'll stop it there.